Hi, I'm Steve Matthews with Acoem. Today we're going to go through a precision shaft alignment with the AT-200 laser shaft alignment system from Acoem. First thing to cover here is our initial setup. In this system, as with all of our systems, we have a two laser system. So there's a stationary sensor and a movable sensor. Each sensor has a sensor and each side has a laser firing at the other. So the initial setup here, of course, is mounting the chain brackets or optional magnetic brackets to the shafts. And what we have is a large sensor. It's 1.2 inches. And so getting everything roughly set up is fairly simple, as moving the M or the S sensor up and down on the post to get each side roughly in the middle. And you can see the middle of the sensor range is marked by this little triangle. So that completes our initial setup. Now we'll go over to the app and finish the setup and take measurements. So here on the horizontal shaft alignment app, the first thing we're going to do is we turned our sensors on to get started here. And over on the app, what we'll do is check that the sensors are connected to the app via Bluetooth. And if we touch on the settings icon, we can see here that there's a check mark for each of the serial numbers of these M and S sensors. So we know that it's connected. We also can tell that it's connected up here with the values next to the S and M. There's a little green light indicating that the sensors are seeing the lasers and that there are values on the screen. So the final step here in the process is we want to make sure that the sensors are square to one another within about 1 degree. There are values on the screen to indicate that. So for example here, I can look and see that my S sensor is at 14.5 degrees and my M sensor is at 14.4 degrees. So that's certainly close enough for us to get started. Now, the final part of the setup is to input the dimensions of the machine. So that's this measurement icon here. Take my tape measure here. The first step is the distance between the M sensor and the S sensor, which we have as 7 inches. We want to get this dimension within about the closest 1/8 of an inch. And then we have between the M sensor and the center of the coupling, this value defaults to half of the value between the S and the M sensor. And in this case, that is correct. If the sensors are not mounted symmetrically on either side of the coupling, you can change this value. 3.5. So then we have between the M sensor and the front feet of the movable machine. We have these, the demonstrator marked here as movable and stationary. Generally, your movable machine is an electric motor. So the distance between M sensor and the front feet here is, in this case, 0. And then front feet to rear feet on the movable machine. And I have 7 for that. With this alignment tool, the user interface will generally highlight in yellow or green the icon in which should be the next step of the process. So you can see I've got the check mark. Our next step here is to select a tolerance. We select a tolerance based on machine speed. The faster rotating machinery operates, the more close the alignment tolerance should be. So we'll select 1800 as a tolerance. And now we've got all of our setup complete. Now there are a couple of features that we'll go through here that are unique to the AT-200. And we'll do that before we take measurements here. And if I touch on the machine, I get a couple of things that I can do here. Number one is if I touch on the stationary machine, I can select a machine type that matches up with the type of alignment that I'm doing. So for example, here I've selected a pump. The other thing I can do is on the motor side, you can select different colors to show on the motor. And finally, in the coupling icon, there is an opportunity for us to look at alignment tolerances in different ways. So the standard way we look at alignment tolerances is in angle and offset at the coupling. This is for close coupled equipment. In spacer shaft alignments, where you have a spacer shaft or a jack shaft, we can look at that alignment in terms of an angle and an angle. So it's a different way to look at the tolerances, and that's a feature that's built into to this AT-200. There's also an opportunity for us to look at angularity in terms of gap, so many thousandths over the diameter of the coupling. So just some different ways that you can look at tolerances based on what your typical use case might be. So today we'll just stick with our standard angle and offset. And then the other thing that we can do here is input thermal growth tolerances. We won't go through that specifically, but there is the opportunity in an AT-200 to put in offsets to compensate for dynamic growth. So now we've got everything set up. I'm going to go to my measurement icon. And the final thing I'll cover here is the different measurement methods that we have in an AT-200. Today we're going to do this alignment in express mode. Express mode is helpful if you're operating the tool by yourself. It takes the data automatically. You can see here it has begun sampling the data as I'm standing here. I'm going to just go back and show the other methods here. We have tri-point, clock mode, and clock mode without angles. And there are some specific applications where these options are favorable to the tri-point or the express. Again, today we're going to finish the alignment in the express mode. The difference between express and tri-point is primarily that you have to engage the measurement with a physical press of the button or the icon in tri-point, although the measurement methods are similar. So again, we'll go back and do this alignment in express, and when I roll it down, roll it back up, and hold it still, that's when the measurement starts. It's important to hold the shaft still while the measurement is taking place. So we rotate outside the red zone, and again, once I hold that shaft still, it will automatically begin measuring. And now I can start anywhere and stop anywhere. In this case, I'm going to stop in the horizontal plane because I want for my values to be live in the horizontal plane when I go to do my adjustments. But with this tool, we can start anywhere and stop anywhere as long as you rotate outside that red zone. So now we've got our alignment results presented. At the top, we have angle and offset for the motor. At the bottom, we have angle and offset for the vertical, angle and offset for the horizontal. And then the correction values here. Now the other thing I'm going to do here is reorient this picture. Initially I had this picture oriented with the movable element on my right side for my view from this side of the machine. What I've done just now is reorient the picture so that the movable element is on this side for the orientation from this side of the machine, for the benefit of the camera. So you can see this, when we evaluate this data, we can see that all of the alignment values are out of tolerance. So we'll need to make these corrections, and the way that we do that is to go to shimming. So typically we make our vertical alignment first, and in our case what we'll do is what we at Acoem call a vertical alignment, meaning we'll do a vertical adjustment and a horizontal adjustment at the same time. So here we have the vertical values, and it shows very clearly with an arrow whether the shim should go in or the shim should come out. So this makes some sense of the plus and minus numbers that you saw on the first presentation of results. Here it's very clear whether that means I have to add shim or take away shim. So we'll make these adjustments. I have some shims prepared here. 20 thousandths in the front. And 35 in the rear. Now, at this point, I'm going to leave these bolts loose here on the movable element because my next move is going to be a horizontal adjustment. We'll do that by touching the horizontal icon that's highlighted. And momentarily, we'll have live results with arrows that are scaled as far in terms of how far I have to move the machine. So the rear feet of this machine need to move approximately 29 thousandths of an inch. So I'll start making that adjustment slowly so I don't overshoot. Getting close. Once I get close, you'll see that again those arrows are scaled. I've gone just a little bit too far. And as I get close, you can see that we have the tolerance values, the angle and offset, starting to switch from red to green and orange. Orange means within 2 times the tolerance, and green, of course, means within the tolerance. So as I get this dialed in, now I'm within tolerance. So I'm under 0.7 mils per inch angle and under 4.0 mils offset. Again, the results are in thousandths of an inch. So then we'll just tighten this up. And finally, we'll remeasure. And once we remeasure, we can document this alignment. So once again, in express mode, the data begins automatically once I drop the sensors below 3 o'clock and then come back above it. Rotate outside the red zone. See the lollipop turns green. That means I've gone far enough to take another measurement. And again, while the measurement's sampling, we want to keep the shaft still and not rotating. Then we get to our final measurement position. And we'll have our final results here in just a second. So now we have everything is in tolerance. You can tell that 2 ways. Green check mark on both the vertical and the horizontal. And then the angle and offset values, the coupling icons have all turned green. So the last thing that we're going to do here is document this alignment. And we'll do that, number 1, by saving, and I've got to flip this around to do this. We'll save the shaft alignment data, and then we'll create a report. So those are it's kind of 2 steps for creating the report. I'm going to call this AT-200. Okay, so that just saved my shaft alignment results. and then I'm going to create a PDF report by, I have an opportunity here to put in a plant name, a machine name, a username, and notes. I'm going to skip that, but what I am going to do is select my AT-200 values, a picture of this machine, and a soft foot. And then I'm going to save that. That creates a PDF. And in my PDF report, we'll have the soft foot values, picture of the machine, and the alignment results. So that completes an alignment with the AT-200. If you have questions about this product or any other of our Acoem laser alignment or condition monitoring products, please contact us at the details below.